The second question, second problem. The tension in the spring balance is represented to scale 1 centimeters equals to 20 newtons, where the gravity is 10. The first question is determine the magnitude of the tension in the spring. There is no given here for the tension to calculate the tension, so we're going to use the scale and the drawing. We have the each 1 centimeters is equal to 20 newtons. We use the ruler. Here I used my daughter's ruler. It's 22.5 centimeters. To calculate the tension, we make the cross multiplication. We multiply 2.5 by 20 and divide by 1. And so the tension here is 5 newtons. Okay. Part B, this is the forces. The forces here are tension and weight. Okay. Write the condition of equilibrium of M. Of course, the two forces are the tension and the weight. This is the condition of equilibrium. Please watch out for the vector on the zero. Tension vector equal minus weight vector. We the weight here is the left, the negative sign, the right, sorry. So the magnitude relation is tension equals to weight. This is called the magnitude relation. This is the vector relation. Okay, when they ask you to write the relation, you can write these three steps, the vector and the magnitude relation. While part D, deduce the magnitude of the weight. Weight equals, we cannot calculate weight since we don't have the mass of the block. So we can calculate it from the tension. We can deduce it from the tension, which is equal to weight, equal to 5 Newton. E, calculate the mass. We have now the weight. We can say that mass equals to weight over gravity, which is 0.5 kilograms. Give the characteristics of the weight. The four characteristics are the point of application, which is the center of mass, or should we say the center of gravity of the block. The line of action is vertical, and the direction is downwards. Okay, so and the magnitude is calculated from the tension weight equals to 5 newtons. Represent the forces acting on M on the same diagram. So now we know that the tension is upward and the weight is downward. List the forces of interaction between S and M and then deduce the magnitude. The forces of interaction are Fs over M. The spring pulls the block upwards and the block pulls the spring downwards. These are the two forces, Fs over M and Fm over S. It is the force exerted by S on the M, on the block M, and M on S, the force exerted by M on S. Okay? So to calculate or deduce the magnitude of the forces exerted by the block on the spring, Fm over S. We now need to calculate this the magnitude of this force. Okay, we know that the Fs over M, the force exerted by the spring on M, is the tension force. The tension is the force exerted by the spring or string on the object. So this is equivalent to the tension. Okay, it's 5 newtons. It's given or calculated in the first part. Now, the force exerted by the mass on the spring is equal to Fs over M. This is the principle of interaction. So Fs over M equals Fm over S, which is 5 newtons. This is the principle of interaction. The last part represents the forces of interaction between S and M. Okay, by representation, they both start from the same point, which is the point of contact. Since this is the point where the spring pulls the block and the block pulls the spring, this is the same point. The force exerted by the spring on the mass and the force exerted by the mass on the spring. Thank you.